Okay, brilliant. So thank you for the introduction. My name's Hannah Gumble, and I'm going to be presenting on conceptualizing and mapping an index of multimodal travel opportunity. So before I jump in, I just want to take a step back and go through the overview. So I'm going to start with an introduction followed by a short literature review, then go over the research questions, the study area and the data, present the methodology and the results, and then finish with a discussion and conclusion. So public transport is a key part of everyday lives. And most public transport trips are multimodal. So what is multimodal travel? So it's where two or more modes of travel are used within a single trip. And multimodal mobility is seeing a lot more attention and an increasing focus, with the EU Transport Commissioner calling for 2018 to be the year of multimodality, where legislation and policy looks at improving multimodal travel. And there are several reasons for this. The first one is the potential to reduce congestion. The second one is the ease of overcrowding transport corridors. And the third is to mitigate the environmental impact of travelling. So within this study, what do we mean by multimodal travel opportunity? It's the opportunity and want for an individual to undertake a multimodal trip. So to give it a brief overview of the literature, factors that affect a person's want and opportunity to travel can be broken down into two groups. Physical, so things like network characteristics, the extent of networks, their connectivity and the physical access. And then non-instrumental constraints. So these are more psychological factors that affect trip satisfaction and experience. So for example, what is the environment like that the person is travelling through? Is there a lot of green space? Are there trees? Or is it very crowded and cramped? And how safe do people feel travelling through there? So research into multimodal travel is limited, with many studies focusing on a single mode in isolation. And this is mainly due to the complexity of analysing trip chains, but also data availability. But it leaves a gap not understanding the impact of things like changing facilities. So is there an adequate waiting room, or are people standing on the platform in between changing modes? So of the studies that have focused on more than one mode, the focus is mainly on physical barriers, even though many studies have discussed the effect of non-instrumental constraints. So in the right-hand corner, I have an image from Curtis et al. 2012, and they done a spatial network analysis for multimodal urban transport systems for Australia. So they assessed the relationship between public transport, network performance, and land use to create a composite index. And it encompassed things like nodal catchments, nodal connectivity, and the number of transfers. One of the key things this work highlighted was the need for a visual representation of multimodal accessibility to help facilitate understanding. So the research questions. So the first one is, can a methodology be developed to spatially quantify multimodal travel opportunity into a composite index? The second is, how could we conceptualize and measure these non-instrumental barriers? And lastly, what insights can be derived from the application of the methodology within Hertfordshire? So to introduce the case study, Hertfordshire is a county north of London. It's comprised of 10 districts which are highlighted in the green boundaries, and it has a very dispersed population, which can be seen by LSOA, so the lower super output area boundaries, where the smaller they are, the higher the population is. And it's a very dispersed population, so the county has high level of car ownership and also a rising number of air quality management areas. So to give you an idea of what they think the future will look like, by 2031, there'll be 18% more cars travelling in peak periods, and the average travelling speed will reduce by 15%. So therefore, their local plan really wants to challenge this behaviour. It wants to encourage walking, cycling and passenger transport. So given this index only includes walking, cycling and passenger transport and not cars. So the data used was a mix of private and public data sets, of which there are many. Some examples included census data, boundary data such as the lower super output areas, bus stop locations, traffic calming measures, Fix My Street data, which is a crowdsourced platform that was used as an environmental quality proxy, and railway data, including average delay and the percentage of services cancelled, and also things like are there waiting room facilities or facilities for an individual to park their bike. So this is an overview of the methodology, and the methodology has 9 key steps. So we start by thinking, okay, what should we include? And we identify the trip determinants from the literature. So what are these things that hinder a person who wants to undertake a multimodal trip and therefore affects their options? And then we develop a theoretical framework. So we look at how these variables fit together and try and create a logical way of piecing them together. We then collected our data and done cleaning and verification, and then it split off into 2 separate pathways. One was to calculate and measure area attributes, and the other one was to calculate and measure railway station and bus stop attributes. And I'll explain why they are done separately soon. And then we've done data exploration. So we looked at key patterns and trends of the data, what could be seen. So for the area attributes, we then undertook principal component analysis as a method of data reduction, and analytical hierarchy processing was used to weight the components. Then space was incorporated to the index through network analysis, and that resulted in a visualization. So the first thing I wanted to show you was the theoretical framework. So this was done by understanding what we needed, and we wanted to create a framework to organize it. So there are many key components, which are highlighted by the light yellow boxes, and then 6 main domains. And these are split up into area attributes and location and proximity. So area attributes were all measured at an LSOA level, and location and proximity attributes looked at where the location of the railway stations and bus stops are, and the catchment of those areas for walking and cycling. So those factors are only relevant in a specific catchment and proximity, and therefore cannot be captured by a whole LSOA. So I just wanted to give an overview of how one of the non-instrumental components were calculated, seeing as that these are very psychological, they're quite abstract. So the one I'm going to talk through is network illumination ratio. So on the right, there's an image of like the starting data. So we have lighting, so street lamps, the highway network, cycle paths and footpaths. And what we wanted to do was really understand what proportion of the network had adequate lighting and which ones did not. So to do this, we done lots of reading and identified a lighting radius. So a street lamp on average illuminates a certain area. So we used that to buffer the street lamps. We then intersected the buffers with the networks and calculated a ratio of sufficiently lit networks divided by unlit networks. And this then fed into the safety domain. So principal component analysis and analytical hierarchy processing. So principal component analysis is an unsupervised method of dimension reduction, which finds pattern in the data without prior knowledge. So principal component analysis begins with original data, creates a hypothetical model, and creates new variables through creating linear combinations of original data, aiming to capture as much of the variability as possible. So as you can see in the graph, for local characteristics, there were 9 principal components captured that explained 100% of the variation. But as you can see, the first principal component explained 85% of the variation within the data. So we used the screen methodology to understand how many principal components to carry forward. So for this one, we used the first one as it captured 85%. And this method was only applied to the area attributes. We then done analytical hierarchy processing because weights are really important in composite indices. So analytical hierarchy processing is a participatory approach that uses pairwise comparisons to derive priority scales. So we ask people to basically rank on a scale how important one element is to another. So this was applied to the area domain, the bus stops, and the railway stations individually. So the table below shows some of the weightings applied to the areas. So you can see that local potential was the most relevant, and then that was followed by safety, which was seen as more important, affecting the multimodal opportunity than connectivity. So this really shows the influence of these non-instrumental constraints. So then we wanted to incorporate space. So space is a key component of the index, and multimodal opportunity is a spatial phenomenon. So it's critical to understand the location and proximity the bus stops and railway stations opportunity applies to. So to do this, we use network analysts. So we said, okay, the railway station is here. Let's use network analysts to create a cycling catchment and a walking catchment for each railway station. And for bus stops, we only considered walking catchments because in Hertfordshire, you cannot take a bike on a bus. And for 99% of the stations, there is no facilities for you to store your bikes at bus stops. So that's just one thing to bear in mind. So after this, we have three layers. We have the LSOA area attributes, the bus stop scores, and the railway station opportunity scores. So to combine all these, we use feature to polygon, which created smaller polygons based on overlaying segments. And then we use spatial join to aggregate the opportunity scores into one indicator. And this resulted in the index of multimodal opportunity. So this, what you can see now is the AM results, which covers the period from 7 AM to 10 AM. So the outputs, for an average weekday, we have results by time period, so from AM into peak and PM. And then for Saturday and Sunday, we look at results over the whole day. So I'm now going to flick through the results to highlight some of the key differences. So what I've done is that I've circled three key things that I'm going to look at, and I'll go back and forth for you to be able to see the differences. So this is the AM, and this is the PM, which represents 4 till 7 PM. And as you can see in circle, there's a reduction of low scores, which mean there's less opportunity in the PM as connections are not available. And in the circle 2 in the southwest, you can see the change of the orange score from 9.1 to 12 to less than 9, where it turns green. And in circle 3, there was also the disappearance of opportunity in the southwest. So the area goes from green really to blue when connecting the two towns. Overall, you can see that there is many large rural areas showing low multimodal opportunity. So for the people that live there, there really is very limited connections and availability for them to travel in a multimodal manner. And now we're going to look at Saturday compared to Sunday. So overall, if you look at Saturday compared to Sunday, there's a really big decrease in the multimodal opportunity scores. And this can really be seen in circle 1, where the cores of the towns, which are sort of red and orange, go down to being a really low orange to green or blue. Okay. And for area 2, a similar thing can be seen, but we also see the reduction of a sort of travel corridor towards the north, which has a value of 1.6 to 3.5, and that disappears within a Sunday. Okay, so there's those key differences. So back to the research question. So the first question was, can a methodology be developed to spatially quantify multimodal travel opportunity into a composite index? So the answer is yes, it can. A methodology can be devised and a composite index can be calculated. However, the reliability and representation of an index can always be challenged. So indicator selection is inherently subjective even if there is an overarching framework. So we try to be as comprehensive as possible, but there is a chance that an indicator was missed in the calculations that could affect the results. Furthermore, weighting was applied to the composite index at an aggregate level. However, it is likely that the importance of variables may change when considering different trip purposes. So the weighting tried to be as representative as real opinions as possible. However, they had to undergo some sort of aggregation. And different trip purposes and population subgroups have different values of time. So if someone is traveling to work, their value of time is higher than someone who's making a leisure trip. And as we do look at trip purposes and population subgroups differently, there is some aggregate results. The second question, how could we conceptualize and measure non-instrumental barriers? So the methodologies for calculating non-instrumental constraints, like the illumination ratios that I showed you, were developed. However, it must be reminded that this is one approach. It's sort of subjective to the researcher understanding that phenomenon, and it is only one approach and one way in which these could be conceptualized. So the variables were measured from numerous data sets, which are subjected to different understanding of data reliability. So the first one is locational accuracy. So when something is represented in GIS, you hope that it is as accurate as possible, but there is always that chance that it could be offset. And although we try to clean and verify data as much as possible, this still could be in there. And the second one is through using the LSOAs to capture the area attributes. They were somewhat constrained by the zone's crisp boundary. So in real life, many spatial data sets are not as clear-cut and would have a sort of transition period. But through using LSOAs, it says the result of one place is this and the result of the neighbouring place is that, but that boundary in the middle could be more fuzzy. And it can be argued that it could suffer from the modifiable area unit problem, whereby using a different zoning system other than LSOAs, you could get different results. So what insights can be derived from the application of the methodology within Hertfordshire? So the case study shows there is a greater amount of multimodal opportunity in urban centres compared to rural areas, which is expected. That is something that you would expect to see. You can see that the spatial nature widely varies. The index can be used to support understanding of gaps within public transport services to improve continuity in service provision and multimodal opportunity, particularly for the key travel corridors. So you can see evidence of north to south travel corridors, even if they are still of low multimodal opportunity. But there are little east-west connections. So in Hertfordshire, the results were driven by the availability of bus services due to the number of bus stops throughout the county. And it could be argued that by using those and introducing new routes, you would see those multimodal opportunity scores increase. So to conclude, the research aimed to create a methodology for a composite index summarising multimodal travel. It encompassed both physical and non-instrumental barriers, although the non-instrumental barriers were experimental in conceptualization. The framework presented allowed for the spatial nature of multimodal opportunity to be explored. In the case study, there were higher areas of multimodal opportunity in town centres rather than rural areas. In seeking to fill a research gap, the effect of non-instrumental constraints was explored and conceptualization was undertaken. Further studies could use and test the non-instrumental measurements and explore differences between different individuals and trip purposes. So as a kind of concluding sentence, it could be argued that by quantifying and understanding the spatial nature of multimodal travel opportunity, infrastructure and policies that aim to increase multimodal travel can be refined and become more effective at encouraging individuals to undertake multimodal travel. So to have some references, and thank you for sitting through the presentation and also giving me the opportunity to present. If you have any questions, please don't hesitate to ask.
Thanks very much for that, Hannah. That was a really interesting presentation, and thanks very much for keeping on time. It looks like a great piece of work. So I'll open the floor, or open to the floor for questions now, if anybody wants to ask Hannah anything about her research. You can use the text chat and then I can gather them up. Perhaps while we're waiting for people to maybe type in their questions, I just have one. Could you say a little bit more about how the composite indexing works? So for the domain weights, so you said you asked people to rank the relative importance
Mhm.
of domains. How was that done, and did you see correlation between people in general, or well, I just like
Yeah.
more how it was done.
What happened was it was like a long questionnaire, and you would have one variable put against another, and you'd rank that on a scale from low importance to high importance. So that's done for every possible combination of attributes, and then you put that into a calculator, and it gives you the percentages, so the weights to apply. So we've done that for a numerous amount of people, and we took an average then of the weights, and we looked at the patterns and the sort of variance between them, and they were very much on the same sort of track in terms of weighting. So that was something that was really interesting. Like, although there was a little bit of difference, it wasn't as big as you might have expected. So then we applied that to give a value for the area attributes, the bus stops, and then the railway stations individually. So you weighted every single component within them, and then that gave you a single factor.
It's interesting that people were kind of aligned in their views or in their thoughts on that. That's what kind of I was interested to see. So I guess I have another question. Um, you talked about the data that you had access to, and it was a mix of public and private data.
Mm-hmm.
Was there any data that you couldn't get but thought would be really beneficial for your study? Because that's a challenge that I have a lot with my projects is if only I had this data, I'd be able to answer the question much better or do something differently. Did you find the same thing, or is there something missing from the data?
Yeah, most definitely. And some of the data that was provided, there was a lot of sort of errors within it. So I've received bus route data, but all of the bus routes are actually really outdated. So I could have done with more up-to-date relevant bus route data, because once I cleaned that, I was only left with a proportion of routes and services. So that is one of the ones I was kind of missing and lacking in accuracy.
Okay, yeah, that's the thing. Up-to-date data is always going to be beneficial, but it can be difficult to get.
Yeah.
So there's some questions that have come in now, and I'll just read them out. So connectivity was ranked as less important than safety. Could this be an effect of the sample interviewed? For example, might there be some groups of commuter car drivers who would rank connectivity much higher? So I guess that's related to what I was asking there.
Mm-hmm. So yeah, if it very much could be an effect of the sample. I mean, we tried to be as wide covering as possible. I can't remember exactly how many people we got to do it, but it was a big sample. And we really asked people to say, okay, you have to imagine you can't travel by car. How would you then feel about these things?
Yeah, it can be difficult to get a lot of people to consider that. Then they're very
Yeah.
attached to their cars.
Yeah.
Okay, so there's another question then. So you mentioned that cyclists couldn't easily take buses because of the lack of infrastructure. There's been quite a push for new cycling infrastructure in the past months. Would it be possible to use this tool to understand where which investments could perhaps be prioritized? And that's actually something I was wondering myself as well. So, like, can you use this tool to say if you place a bike stand here beside this bus stop, you're going to increase the X amount?
Yeah, so the tool can be rerun. So what happens is you can put in some changes. Say, okay, if we add a bus route here, if we add cycle infrastructure here, and allow people to then cycle. So you would add then the dimension of a cycling catchment to the bus stop. It could then be rerun to see the degree in which it increases multimodal travel opportunity.
I think that could be really interesting and really valuable for like people who are rolling out the infrastructure and looking for places and like the right places to place bicycle
Mm-hmm.
stands, for example.
Yeah.
Okay. So I don't see any other questions coming in. I just have one last final quick question. What's the next step with this? So you're a PhD student, are you?
Yes.
Okay, so this is all contributing to your PhD. What's the next step in this?
So this is actually separate to my PhD topic.
Okay.
So this represents my master's project. But one of the ways in which I want to create it further is by doing a second case study. But because the data is so variable in which local councils have in terms of what they have and how they also manage that. It is quite difficult to then just rerun the process very quickly. So it would be partnering with somewhere else and then really looking at that. And also, as I said, exploring the non-instrumental constraints further to see, okay, I've presented one methodology or way of doing those. How could we explore different methodologies based on different people and then aggregate them into something meaningful?
Okay, that's interesting. There's just one last question that came in. I think it's related to what you were describing there. So are you planning on applying this to other areas? I wonder if the principal components would be different for different areas.
So I'd like to apply it to other areas, but the principal components would most likely be very different because it depends on the variation and patterns seen within the study area. So that will, and because it's an unsupervised sort of technique, it doesn't learn from data and therefore tailor its response. It's okay, what do I get as an input? Let me work with that and then give me an output. So it would probably be quite different, but that is something that I could compare.